The economy of the world has been growing rapidly, as well as the technology which has evolved through the years and made everything easier to do. Thus, many experiments were done, such as the effect of rice's composition on porous concrete performance. One of the types of concrete is called porous concrete. It was developed to support land development and, and surface runoff management. It consists of fine, coarse, cement, and water aggregates. Fine aggregate is one of the constituent materials that play a role in influencing the strength of porous concrete. In addition, the hollow cavities in porous concrete cause its comprehensive strength to be relatively low. Nonetheless, concrete materials are reliant on natural resources. One of the natural resources used is rice husk. It is a cheap material collected from agricultural waste, which can be used for concrete. When processing rice through a milling machine, a byproduct is produced in the form of rice husk. These are waste from the rice milling process, which weighs 20 to 22% of the weight of rice. Every ton of dry rice produces 300 kilograms of rice husk, meaning the production of rice husk is about 30% of the total weight of the rice harvest. However, the use of rice husk was still not optimal. This is due to the characteristics of the rice husk, which are coarse, have low nutritional value, have a low density, and have high enough ash content. Additionally, rice husk as the biomass into the porous concrete can affect the strength and hardening of the porous concrete. Rice husk can be used as the fine argument in porous concrete materials. It is used as a unique and effective roll material that is environmentally friendly. It captured rainwater and allowed rainwater to seep into the ground. Porous concrete material can help replenish groundwater reserves and reduce surface runoff. When applied to the road shoulder, the water runoff from the road can be absorbed into the ground and reduce the drainage channel's water discharge. To determine the effect of rice husk composition on porous concrete performance, an experiment was conducted. First, gravels were washed and dried into the sun for 2 hours, then mixed with cement and water. Second, prior to use, the rice husks were put in the electrical furnace for about 200 to 2500 Celsius for 90 minutes. Thereafter, the rice husks were sawmilled, sieved using a test sieve, and mixed with gravel, cement, and water. 5 mixtures were prepared with varying percentage of rice husk: 1.5, 3, 4.5, 6, and 7.5%. Next, percentage of rice husk added to the concrete is calculated based on the mass of water used in the formulation. Then, the composition of gravel, cement, water, and rice husk carried out are shown in the table 1. And finally, the mixture was poured into the mold made of wood, which is 15 times 10 times 3 centimeter, and dried in the sun for 2 days. As for the appearance, the concrete has a gray and brown color. The brown color in the prepared concrete was due to the rice husk percentage in the mixture. Concrete with a higher percentage of rice husk appeared coarser and rougher than the low percentage of rice husk. Increases in rice's percentage in porous concrete mixture resulted in browner color and coarser surface. Meanwhile, the rice husk particle has a brown color, therefore contributing to the brown features when followed and prepared porous concrete. As for the result, for comprehensive strength of porous concrete, higher rice husk percentage improve the comprehensive strength of porous concrete like as shown in the figure. The hardest porous concrete was achieved by the 7.5% sample, whereas the lowest was achieved by the 1.5% sample. The hardness feature of the porous concrete was correlated to the adhesion factor of the aggregates. Rice has high silica content which is 80%, making them a reactive fossilized. The silica in the rice husk reacts with the side products of cement and water. Hydration results between cement and water produces calcium hydroxide, which can be turned into a hydrated calcium silicate, making the concrete structure more compact and improving its comprehensive strength. To determine the effect of rice husk composition on porous concrete performance, a test was conducted in terms of density, which is expressed as density equals mass over volume. Water pass wherein a 100 milliliter water is pouring gradually on the surface of the porous concrete. Then, the volume of the passing water was measured. It is expressed as water pass percentage equals volume of the passing water over 100 times 100. And lastly, the absorption test, which can be calculated using equation W sub A equals W sub 2 minus W sub 1 over W sub 1 times 100%, where W sub A is water absorption percentage, W sub 1 is the dry sample weight in terms of grams, and W sub 2 is the wet sample weight in terms of grams. Thus, the lower the mass of the concrete, the lower the density value of the highest density value, namely 2.167 gram over cubic centimeter, was owned by the percentage of rice has 1.5%, with a concrete mass of 975 gram, and the lowest density value, namely 1.978 gram cubic centimeter, in the variant with a percentage of 7.5 rice has, the result obtained decreased density along with the addition of rice husk composition and reduction of coarse aggregate mass. This reduction in coarse aggregate is proportional to the decrease in the concrete mass, with a concrete mass of 890 grams. For porous concrete, the addition of rice husk with different variation experience different results in the percentage of water escape. As can be seen, the higher the percentage of rice husk, the lower the percentage of water escaping. This is due to the composition of coarse aggregate, which is also getting reduced along with the addition of rice husk. The coarser the aggregate used, the more pores are produced. Therefore, the highest percentage of escaped water was in the coarsest aggregate variance, the smallest percentage of rice husk. Regarding the pores in the water pass test, it was also found that the rice husk filled the pores in the concrete. Based on these facts, it is proven that the greater the percentage of rice husk, the higher the water absorption capacity of the concrete. This is confirmed by the statement that rice husks can absorb much water because they have a very high porosity, for about 79%. Water absorption in concrete is greater due to the high porosity value of rice husks. The highest percentage of escaped water was found in the percentage of rice husk 1.5. 3% with the result of 100 percentage of water escaped. The lowest percentage was found in the percentage of rice husk 4.5. 7.5% with the result of 0% of water escaping. Meanwhile, the result of the percentage of water absorption with the addition of rice husk with different variations experience differences. This is because the higher the percentage of rice husk, the more water is absorbed by the concrete. For the conclusion, concrete with a higher percentage of rice husk is brown and has a rough surface. A higher percentage of rice husk addition has an impact on the higher comprehensive strength value and percentage of water absorption, while the percentage of water escapes is less. The addition of rice husk to the concrete mixture is recommended because rice husk contains silica that can react with the results of the reaction of cement and water, namely calcium hydroxide, turning it into a hydrated calcium silicate, making the concrete denser and increase the comprehensive strength of the concrete and its porosity value.